Hi there guys, in this video we're going to have a look at modelling with logs, and one of the models we've got to get a good understanding of is this one here. Now if I start off by just asking you to think about what numbers could go in here for these two constant values, you might come up with something like, I don't know, let's make a2 and x, something like that. That is a model. You could make the a1, something like this. So all of these graphs, they fit that model. So let's imagine we've done an experiment, whether it's in science or mathematics, and we've got some data that looks maybe a little bit like this. And we're thinking, yeah, that looks like a model that could be represented like this. And we want to find out what this actual value of a is and what this actual value of n is. So we could use logarithms to actually find those exact values. So let me just pop in my y and my x. So how we do this is we take logs to both sides. And that is as simple as writing log in front of both sides. Now you need to understand your log laws here, and you can see that these are being multiplied. So you can use the multiplication law, if that's what you call it, and separate them. And the next thing I would look at is this power here. So because we have a power of n, using the power law, we can bring that down in front, like so. Now, when you look at this, this should look somewhat familiar. We've got a variable. We've got another variable with log written in front of it, and we've got these two constant terms here, there and there. We've got a plus in the middle. So when before have you seen a variable equals a constant variable term plus a constant? Maybe something like this. We have a variable, a constant and a variable, and another constant. Straight line graphs. So when we get to this stage, we are trying to link this to a linear graph. Now, so let's think about drawing that linear graph. What would it look like? So instead of y and x, because we can see we've got this exponential model here, our variables are going to be log y and log x. And let's say we've just done an experiment and we've got some data points in here, don't know what they are. To get these, all you've got to do is just draw another table underneath, but call it log x and log y. So you just put log and then that value, and you'll get a new value. Log of that one, and you'll get a new one. Again with the y's, and you would plot those. And what you'll find is it will always be a straight line, because it is a straight line linear model. So I'm just going to make up some numbers here. The reason I'm making them up is because I don't actually have these figures. There are plenty of questions in your book where you could, you actually have a table of values, you can actually work these out and draw them. So let's go 1.2 and 0.2, something like that. In fact, let's make it a bit easier. Let's make that whole number 3. So if we think about back to this, we know that is the gradient. So the constant on the constant variable term is always my gradient. So here's the constant variable term, and that constant must be my gradient. So therefore n is the gradient. And the constant term all on its own is the y-intercept. So here's my constant term without an x, without the variable attached. So therefore log a is the y-intercept, which means n from my made up numbers must be 0.2, and it means log of a must be equal to the y-intercept, which we can see is 3. Now I haven't written any base values here because I've just used log, and I could have used natural logs with a base of e. As long as I did the same to both sides up here, that's absolutely fine. But because I've used logs, I'm going to say that a is 10 to the 3 using my log laws. Okay, which leaves us to write y is equal to, I'm going to call that 1000 now, it's just a bit easier to see. Remember, we're designing it for this model up here. So 1000, that's our value of a, x and our value of n is 0.2. So based on this data here, that would be our model. Okay, well, I hope that makes sense. In the next video I'll do the other one, and you'll start to see patterns between them.